Hey guys, what's up? So today I'm another coding challenge. Today we're going to be trying to estimate the value of pi. Maybe just like a couple of digits, let's say 4. But the rest of the digits will probably just be like random digits. So today we're going to be estimating the value of pi using this algorithm that I'm going to put a link in the description. And it's basically where you have a circle inside a square, and like with some algorithmic logic, you basically just you know that the value of pi is basically the area of the circle divided by the total area of the whole square times 4. So for example, over here, I'm just gonna show you. Yeah, so there's a formula. Formula equals to so the formula is pi, okay? So pi, the value of pi is equal to 4 times, I think I'm just gonna, 4 times the circle area divided by the total area, okay? So, I'm just gonna visualize it in the canvas over here. Just auto refresh, make this. And by the way, this is in JavaScript using the p5.js library, as you can see, p5. This is their code editor online, as you can see. It's a really good editor. You guys should also use it. What we're going to start by doing is we're going to create a function constructor that is going to be called dot. So it basically creates new objects for each dot. Okay. So I'm going to pass in x and y. This dot x equals x. This dot y equals y. And obviously I'm going to have a display function to show it. Function, and I'm going to fill this. Let's make red dots, okay? So 25500, that's RGB, and then ellipse, this dot x, this dot y, and let's make them 4 and 4, okay? So they're going to have a diameter of 4, a vertical and horizontal diameter of 4, okay? And now we're going to have a array that has all the dots. It's going to be an empty array, and then we're going to make a for loop in the function setup, the first function to be run, and we're going to have, let's say, 100 dots. Let's start with 100 dots, and then dots.push. So this is we're going to make a new instance, so new dot, and then we're going to pass in random variables for the x and y. Let's do math.random times the width. I think I missed another bracket there. Times the width, and the width is just a p5.js a variable that basically just the value of it is basically the width of the canvas. Okay, and then we can also do math.random times height. That's the height of the canvas, and then to display it in the function draw, which is where basically whatever you see in the canvas. Var I equals 0. I should be smaller than dots.length. I equals plus, and now we're going to do dots I.display. Yeah, so that's how you show up that many dots. Okay, and just so you wondered how did that suddenly show up, it's because I have it on auto refresh. So okay, you can also change the number of dots, so stick to 1,000, but 1,000 is pretty good. Our next step is to actually make the circle. So fill. This could be a transparent circle, so I'm going to do 0, 0, 0, but it's kind of a stroke, so like I can see it of 255, which is white, and no stroke, so the other stuff don't get affected. And then ellipse, which is the p5.js function to draw a circle at 200, 200, because that's the center of the sketch. And then the diameter 400, 400. Yeah, there you go. Okay, so that's a transparent circle. So now what we have to do is basically find out how many dots there are inside the circle, which basically says the area of the circle, and then we need to use the formula. Where's the formula? Okay, so the circle's area, I'm just gonna put that as A, circle A, total A, and circle A. Okay. So that's basically going to be how many dots there are inside the circle. That's going to be the area. So and then the total A, the area of the square, is going to be the number of dots in the whole square. So including the circle. Okay. So let's say how many dots we have. We have 1,000 dots, we can do the value of pi equals to 4 times, let's say there are 750 dots in the circle, divided by, let's say there are a total of 1,000, because we did 1,000. And that would be equal to 4 times 0.75, which is equal to 3.6, I think. Maybe search that up. 4 times 0.75. Oh, just 3. Okay. Where did I get 3.6 from? Okay, whatever. Oh yeah, of course. Yeah, that makes sense. Yeah, so it's 3. So it's 3, and the value of pi is something like 3.1415, and then so on. So we're basically going to do this, but it's going to be more accurate, obviously. And then we're going to estimate the value of pi. Yep. So let's go ahead and do that. Yeah, so we're basically done. Like, we have the visual stuff, and now we just have to make the algorithm. What we have to do, we need to check if the circles or the dots are inside the circle. So we're going to do if. This is going to be a p5.dist function called dist. If the distance from dots i.x, dots i.y, if the distance from that coordinate to 200, the center of sketch, which is over here, if that is smaller than 200, and basically what this does is, let's take, for example, this dot over here. If that is, if from there to the center of the sketch, which is over here, is smaller than the radius of the circle, that means that it's inside the circle, okay? So it kind of makes sense, that logic over there, okay? So then we're going to do, we're going to have a local variable for the function. So var num for the number of, I'll just do inner, okay? So inside the circle equals 0. And the inner plus. Yep. And now to get the value of pi, we can just do var pi equals to the formula. So 4 times the inner divided by the outer. Inner divided by the total. And the total is basically how many dots there are, so the dot length. Okay? And now if we actually print that, we can't, I'm actually going to make it more visual. So I'm going to go to the HTML file and go to H3. Not go to H3, make a H3 element. And I'm just going to name it ID equals X sketch. And then I'm going to, in the draw function, I'm going to do document.get element by ID X dot inner HTML equals pi. Yeah, so as you can see, it's 3.032. So I think I'm just gonna make the margin say 20 pixels. There you go. Okay, so yeah, you can see that's 3.02, but if we do it again, we're gonna get a different number, 3.136, 3.144. You can see it's pretty close to pi. But that it gets closer if this number is larger, but the larger the number is, the more laggy it gets. And the reason why I'm saying it gets more laggy, because we're gonna do this over and over again, and we're gonna store this number over here like several times over and over instead of just clicking run. I'm just gonna do this over and over again, and then I'm gonna find the average. Okay, so yeah, let's go ahead and do that. How will I do this? Okay, I think I'm just gonna, this is pretty easy. I guess I'll just copy this, and at the end of this, I'll just do docs equals to this, and boom. Yeah, there you go. So as you can see, it's basically happening really fast. It's calculating the value of pi, like the approximate value of pi, with these number of dots. It's going over and over again, because I think the draw function is like 52 frames per second. It runs 52 times per second. You can actually change that, but I'm just going to keep it at 52 or something. And now we have to store that, the estimated value of pi in an array, so var values, let's say. This is going to be a global variable. And values.push new, pi. Yeah, there you values are push pi. Okay, so now every time this is running, it's storing this variable, this number over here. Okay, and now I'm gonna create like a button so the user can say stop. So button and button h3 and h3 and estimate. Yeah, there you go. And on click, so when it gets clicked, we're gonna run the function called just next, I guess, because the next thing to do. Function next. I'm going to do no loop, and no loop basically stops the whole the draw function. So like it won't. I'll show you right now. So when I do estimate, then it just stops. Okay. It basically, because the draw function it gets run repeatedly, so no loop just stops the draw function from running. Okay. And now I'm going to do create another h3 x2, and I'm also just gonna copy this. x2.innerHTML equals to average plus. Oh, and now we have to calculate the average, so I'm just going to write average. And this over here is going to be a variable that we're going to calculate right over here. So var average could be a local variable, but you can obviously make it global. Var average equals 0, for var I equals 0, I should be smaller than values.length. So we're accessing all the values that we stored, like all these values. And then we're going to do average equals average equals average. Oh my god, yeah, there we go. Plus values I. Okay, so we're basically finding out the average, and then at the end we just do average equals average divided by values.length. So this is how you find the average. You basically add up all the values, and then you divide by how many values there are. Okay. Yeah, so when you do estimate, the average is 3.139 blah blah, but if you do it for longer, you get closer to the value of pi, hopefully. So when you do run again, I'm just gonna wait for some time. What's this? I is already defined. Yeah, that's fine. Okay. And estimate 3.1404 blah blah. The highest I've ever gotten was like 3.1415, and then it just like kept getting like random numbers like this. Yeah, so that's how you do it. And if you want to see like higher accuracy, you can just do like 7,000, let's say, or maybe even 6,000, 7,000. I'm trying to make this number like a longer kind of 8, 9, 10. Yeah, as you can see, when it's like 10, it gets kind of. Oh, I know why. It's because over here. Okay, yeah. There you go. 10. Yeah, as you can see, it gets like much laggier. Which is why I'm also going to change this into a diameter of 2 and 2. Like each dot is going to be having a diameter of 2. Yeah. Yeah, 10,000 way too laggy. I think I'm going to just make it 7,000. 7,000. Which means I also have to change this over here into a 7,000. Yeah, and now you can see it's like a larger number. Like it's like it has more digits, and then the circles are also much smaller. The dots are much smaller. I meant because I made the radius 2, or the radius 1 and the diameter 2. Yeah. And then when I click estimate, I get 3.1421 blah blah. What if I click estimate? Okay, whatever. Run again. Let's just do this once more, and then I'm going to see if I can get closer. So, estimate 3.1435. Yeah, so if you just like keep trying, eventually you might get like 3.1415, and I actually don't know if you'll get more than that. So, yeah, thank you for watching this video, and I hope you learned something. I hope you learn how to code this, and yeah, I'll see you in the next video.